Hello, everyone, and welcome to Off the Tangent podcast with me, Zak Bream. My guest today is Jonathan Aitken, who is a robotics professor from the University of Sheffield. Today, we're going to be discussing things ranging from the evolution of robotics and the exciting technology he is working on at Sheffield at the moment. So, please enjoy this episode, and thank you.
I think to get started with, I want to get a sense of how you got into robotics.
Cool. So I guess the way to pick it up is kind of where I came from in my academic journey, because my academic journey is quite varied. I didn't just go, I'm doing robotics and end up doing robotics. I started my A-levels. I did physics, chemistry, maths at A-level. And I knew I was interested in how stuff worked. So I like doing physics, I like doing maths, and I thought, well, for a degree, I'm going to go study electronic engineering. And I did. I did 4 years electronic engineering. I specialised in avionics, so particularly thinking about aircraft, but particularly thinking about how aircraft fly and how you control aircraft. So post-degree, I then went, well, what am I going to do? I need to do something. And I went, I'll go do a PhD. I can talk a long time about PhD. It was a great experience, but as part of my PhD, I fell into topic really of kind of naturally inspired intelligence, looking at how the human immune system works and looking to see if we could take metaphors for how the human immune system worked to apply them to swarm systems. So not thinking practical stuff, not thinking actual robots, although obviously robots can be a swarm system, and that's one application of the work that I was looking at, but purely doing the programming side, purely looking at how we could actually understand how a member of a swarm wasn't behaving correctly.
So I think just to quickly jump in and explain, because I think a lot of people might not know what a swarm is.
Yeah.
Like when you just, my understanding of a swarm is when you have a group of robots who almost can communicate with each other and then sort of do tasks. So you can imagine like maybe like 10 drones flying in sort of unison.
So in this case, what we were looking at was groups of robots. So they would each be doing a particular task. In this case, it was quite a simple one. It was just moving around a particular region in space. But each of them was communicating, and they were communicating how they were moving. And that communication then controlled how the other robots in that swarm would move. So we were using a similar process to something created by Andrew Reynolds called Boids, which is back from the early days of computer vision. So if you think kind of the very first, the early Batman films from the 90s, where you see swarms of birds moving, that is a Boyd's based simulation. There are very simple rules about how you move. You match speeds with your neighbors, you keep a distance from your neighbors, and you try and not collide with them. And we basically applied that process, and we had a nice little simulation of them moving around. But what we did was we changed the characteristics of some of the members of the swarm, which changed the overall behaviour of the swarm. So in other words, some would be moving around with a certain speed. We just slow them down. And by slowing them down, we changed the entire behaviour of the swarm. And what we were then looking to do was to see if the swarm could actually react, pick out the member that was behaving differently, and remove them from the swarm to move back to their original behaviour. So effectively trying to come up with a system to engineer fault tolerance in that particular swarm. We came up with a nice metaphor for doing it based on the human immune system, and it worked really quite well. But that wasn't actual robotics. That was programming, and for a long time I was a programmer. My first postdoc at the University of York was in computer science. And I was looking at arguing how we build software safely, how we can argue that a piece of software in a safety critical application is actually safe to use. So by a safety critical application, I mean something that's going to involve people. There's going to be a human in the loop. There's going to be a human around the system who could potentially be endangered if that system fails to operate correctly. And we were trying to look at how we can particularly argue this for modular systems where you want to build in different components, where each of those components might have its own safety case that's been written for it, but you need to understand the interaction with other components that are coming together. Now, there's a big story around exactly what happened there, but I can leave that.
Yeah.
But then following that, I moved to Sheffield. And I moved to Sheffield as a research fellow, particularly in robotics. The work that I was doing built upon the fault tolerance work that I'd been doing previously, and also built upon this idea of how we argue safety, because I was working on a project with National Nuclear Laboratories and Sellafield looking at how we can develop robot systems that would effectively sit in a cave underneath in the ground and process the Sellafield site to turn it back to a greenfield site. So they would never be touched by humans because the environment would be far too dangerous. But if something went wrong in that system, it had to pick up and understand how it had gone wrong and correct for it.
So what's a Sellafield system? Like, what's the user?
So Sellafield is the large nuclear site within the UK. So it's one of the main reprocessing sites within the UK. It's a plant that's existed for a very long period of time. It's been around since the 70s in various different names, and it contains most of the test reactors and various other reprocessing facilities like Thorpe reprocessing plant, which have been used to process nuclear material to kind of onwards from being in use. The UK plan for that site is to basically have it disappear.
So just let me clarify. So it's like you have all the nuclear sites around the UK, and you might have like nuclear isotopes or material that's still decaying, and it's been used in these plants, and then they would take it and move it to a site to sort of get rid of.
To effectively get rid of, to either vitrify it, to store it, or to reprocess it into other forms of usable fuel material. And that's what the Sellafield site does. The government's long-term plan for that site is to take it from the massive site that it is. When you go round it, you don't walk around it, you'll bust round it because it's that big. To take it back to a greenfield site, to have nothing there. And obviously, there's a lot of material in that site that needs dealing with. It needs handling correctly. It needs correct disposal. And in the case for a lot of the work, some of the buildings that they have in the 70s and 80s, a lot of the stuff when they decommissioned a building was just put into barrels. Now, there isn't material in those barrels there's not kind of fuel rods in there or anything. We're talking retort stands, bits of stools, things that were in labs. But it all needs dealing with. It all needs taking out, opening up, and then sorting through.
Yeah.
And it all has to be done individually. Now, the plan, the preceding plan was to do it with people doing it. But obviously, if you've got humans sitting there doing it, kind of manually running the sticks to move the robots around, obviously you work in shifts and do all this kind of stuff, but the length of time that it would take is crazy for the amount of material that's there. So the way you get around it is to have robots do it and be able to do it 24/7, paralyze everything up and have them work 24/7. The problem is, what happens when something goes wrong? What happens when something breaks? Is it a camera? Is it the robot? Is it a joint on the robot? What actually is it? Can you understand what it is? And then can you correct for it? And the work we were doing as part of that project was looking at how we could actually have a system understand what was going on and then make justifiable decisions for how it was going to change and do something else. So, for example, it could have 2 or 3 web cameras which are giving it a view of the table that it's operating on. If one of them breaks, well, it could remove that webcam, switch to another one, change its processing algorithm to use that webcam instead of data from that webcam, chuck that one in the nuclear waste bin, and order a new one to come in. That's just one example of the kind of thing you can kind of imagine that system doing. On a more mundane level, if you've got a robot, if you've got a 6-jointed manipulator, 7-jointed manipulator, depending on what you've got, and one of the joints breaks, you can use the other joints.
Yeah.
So you get the same behaviour, but you just can't move one of the joints. But again, you've got to understand that within the control algorithms in order to be able to keep manipulating that particular robot. So that was, if you like, was my introduction to robotics. Although, if you look at my path to get to that point, I've done everything else.
Yeah.
Besides the kind of justifiable systems, the fault tolerant systems.
So
As
staying,
part of that,
I was just going to say, stay on the swarm quickly.
Yeah.
I think swarm robotics is something that for a lot of people they don't really know much about. I think when they think of robots, they probably think of like humanoid robots, for example, robots that just it look like humans. What are some interesting applications would you say of swarm? I've seen that at the University of Sheffield they do. I can't remember the project name, but it's one where you have when you have pipes underground, like let's say sewage pipes, and then you'd have these sort of small robots going in there. Have you worked at all on that sort of project?
Yes, so I'm actually involved in that project. That project was called Pipebots, and it's a project to investigate the condition of basically the sewers. Because in the UK, we have a large sewerage network. It goes everywhere. And in order to inspect that sewerage network, you have to send a few guys out in a van, get them to lift a manhole, get them to push a camera into the pipe, and then push it along.
Wow.
It can only travel in straight lines. It can't travel around corners. So you push it down. You probably push it down maybe 100 meters, 150 meters, maybe a bit less. Then you go, great. Now you pull it out again. Then you go to the next manhole and you repeat the process.
Wow.
It's a very, very slow kind of human-driven process. The purpose for Pipebots is to say, well, actually, why don't we just have robots that live in the sewers? They can work as a network, so they can communicate and say, well, actually, just from a tasking perspective, so thinking about what we're going to command the robot to do. If I've been from junction A to junction B, there's no need for another robot to go from junction A to junction B for a period of time, because actually it's already been inspected. So you can start to imagine a collection of robots that are working together, discussing where they've been, and then saying, well, actually, we need to make sure we have as effective large area coverage as possible, and then revisit sites every so often. But rather than just having everyone figure out what to do for themselves.
So when you would have robots like this, would you use robots that use like computer vision that can see where they're going, or would you have almost like a tracker to track its location in 3D space, and then map out the whole of the pipe sewage system, and then how would you sort of do it?
We've looked at various different things as part of Pipebots. So the robots, typically you pretty much throw as much as you can at it. The difficulty you've got with different sensor modalities that you put on the robot is the more you put on, the more power you consume, because we could put LiDAR on there, so light ranging, laser ranging type equipment. We can put webcams on there. Well, the difficulty with pipes is they're dark. So if I want to get an image, I have to put an LED on, light the environment, take an image, and then turn the LED off again, because I'm just going to drain a battery otherwise. So we can use cameras, but they're an infrequent resource. You could use LiDARs as a resource, but they're very power hungry. As part of that project, we're looking at things like ultrasound as well. So actually, can you effectively perform things like non-destructive testing of the pipe? Because obviously the reflections will give you the characteristics of the pipe surface, tell you what's there, tell you about blockages and various other things, and also tell you about where you are, because obviously reflections from an ultrasound will reflect off things like T-junctions.
So the ultrasound, you've got a sensor that sort of sends out a sound wave, and then when it hits a wall, it bounces back and it tells you how far away it is.
Yeah. So in other words, with an ultrasound, if you ping a sound pulse out, it'll go out, it'll hit something, and then it'll come back again. And obviously, given the speed of sound in air, and that's twice the distance, there we go. We know how far away that particular element is that it's bounced the sound wave off. Now, obviously, if you have enough of that information, you can start to pinpoint where you are in a network. It gets a bit more complicated because actually, with the UK sewer network, we don't actually know where all the pipes are.
Okay.
This isn't uncommon.
Why is that? Did they not record? Is there not a set database where they've recorded it all? Or?
Some of it is not recorded. Some of it is recorded very badly. So it's a rough location. So, for example, they may have got the side of the road that it's on wrong.
Yeah.
Or it could just be that actually, with a bit of land movement and a bit of soil movement, the pipe's moved.
I see.
So actually, there's lots of reasons why a pipe may not be where you expect it to be. It may not have moved much, but it's moved a little bit. Now, the overall purpose for pipe bots is to it's to facilitate more efficient mending of pipes when there's a problem. So if you consider that if there's a problem in a pipe, a guy will have gone in with a camera, wound it out. It'll tell them a distance. They can figure out how far the problem is. But then they'll go, right, well, there's a bit of error in that because there's a bit of error in the amount of cable that's been paid out. There's a bit of error in exactly where we've come down. We don't know exactly where that fault actually is. We know roughly where it is. Therefore, we'll dig up 30 metres of this road. Because we know the problem's in that space. And basically, we want to make sure that when we dig the road up, we dig up the bit of road that has the problem in it. Because if it doesn't, then we've got to fill that in and dig somewhere else. The purpose for pipe bots is to say, well, actually, let's not dig 30 metres up. Let's dig 1 metre up. Let's know exactly where a problem is. Because if we can pinpoint a problem exactly, then we have much less disruption. From an economic perspective, much less disruption means less people sitting around all the time. It means freer flow of traffic. It means more movement in the city. It means just effectively a more efficient system. And that's the purpose. That's the purpose of pipe bots. But the swarm in there is basically just an idea of saying, rather than having one robot have to survey the entire country, let's have 1,000 robots surveying the entire country, but they can tell each other where they've been.
So I think this is an interesting topic because it kind of, as you're talking about it, for me personally, I'm thinking, how can you implement it quickly and actually sort of get that in the field? And the limiting factor seems like the swarm, because that seems like quite complicated to implement. Whereas if you just had one bot that, let's say, goes with one of these teams that go out there and try and have to dig up the hole, if they had one robot that they could put down the pipe and sort of send, and then they could monitor its feedback and see, all right, where's the location, and then dig it. That seems effective. Why wouldn't you do something like that? And why are you thinking about the swarm aspect? Is it something to do with how academia is structured, where you think about research more so than like practical implementation quickly? Like what's the reason there?
It is to do with more efficient implementation, because if you say, I have one team with a robot who could send a robot out, well, I still have to have that team taking the robots to its particular position. The issue in the sewer network is, I forget the exact figure, but if you look at the amount of the sewerage network that's actually inspected, it's of the order of a very low percentage. The only way you can inspect that sewer network is to actually deploy a large autonomous resource that goes around looking at it. And to do that, you can't have people going and putting stuff in, because it's no different from the situation at the moment. You also have the issue where you have things like irregular faults. So they're not a fault that's going to show up all the time. They're a fault that'll turn up occasionally under certain conditions. Now, you don't know what those conditions are. The only way you can find it is to regularly sample it or survey it. If you've got a known fault, you can send a robot in there every day.
So would the robot then so it's not for fixing, it's more for locating the issue?
More for locating at the moment.
Okay.
The future progression for pipe bots is a suggestion to then say, well, actually, can you fix it? Now, there are simple fixes you can do. It's a crack in a pipe. Can you put filler in? Can you do something else with it? But the initial task for pipe bots was just locating problems.
Yeah, because a year ago, I did the SURE project at Sheffield, which is like the undergraduate research project for students. And I did it with 2 professors and one of my friends. And the idea was that we could have, so in the Middle East, not just the Middle East, a lot of old and past war zones, you have a lot of mines left over from past conflicts. So every year you get thousands of deaths from people stepping on these mines that are sort of left over. So, I mean, in the EU, you had places like Bosnia that had a lot of mines left over, but now they've mostly been cleared out. But in countries where the government doesn't have as much money, then they can't clear out those mines. So our idea for the SURE project was, we have a swarm of drones I'm sure there's a more efficient way of doing this, but this is just our rudimentary idea. You have a swarm of drones with like metal detectors on them, and then you can send them out over large areas of land, and then they detect where mines are located, and then you can have a map almost of all the locations of mines, and then you can efficiently send teams in to remove them. So the idea was that you could almost like sell this information to different governments around the world in order for them to remove the mines. Now, looking back on it, I did the metal detector circuit. I think me driving the metal detector circuit was mainly because I wanted to learn how to do electronics and do a metal detector circuit, rather than that being sort of a real way that you could do it. But I find this sort of area of swarm quite interesting on how I think early stages of implementation of it would make sense for it be more to locate the problems rather than solving it, because then you're trying to do too many things at once almost.
Yeah. I think that's it, and I think it's. Yes, swarms are complicated, and getting them working and managing them and actually managing the information flow and actually managing the information they produce as well is complicated. So that's a job enough in itself before you then try and take some action. So yeah, it's much easier just to get it to send something and then say, here's where the problem is.
Yeah, literally. So I wanted to talk a bit about like humanoid robots.
Yes.
So I mean, me personally, I think humanoid robots is the thing that I'm very excited about in robotics and sort of the future. And I would say I've had a lot of debates with people about the time scale of how far away we are from implementation of the world of humanoid robots. Because in my mind, you have all of the major companies now, like Tesla, Apple, and a range of other companies, sort of making humanoid robots to be effectively sent out and to be in your home and perhaps do chores for you or jobs and things like that. Or you have other companies working on humanoid robots to sort of be in factories and maybe do jobs like that. What sort of time scale do you think implementation might be? Because in my mind, from the rate at which we're going, I would imagine that you'd start seeing people buying them in their homes in like 10 years to have to do chores around the house. What is your sort of idea on that?
I think it's an interesting question, because if you actually break some of these things down, the home use is an interesting use case for one reason and one reason alone. There are already plenty of robotic systems that will do jobs in the home. So autonomous vacuum cleaners, Dyson has one. Autonomous lawnmowers, you can go and get a Bosch lawnmower and it will actually go around. You put pins around the edge of your lawn, that tells it where it can't go, and it will basically mow anything that's in the middle of that. There are plenty of robots out there that will do bespoke tasks, but also very specific tasks. The thing with the humanoid robot, and the thing that everyone's got really excited about with the humanoid robot, is, it can do loads of tasks.
Yeah.
And it can, in theory, do loads of tasks. When you look at what they're being used for, so if you look at Tesla's work with humanoid robots, that's really interesting, because they've probably gone down a route. Well, they've gone down the same route that they've gone down with their driverless cars, which is, if we have enough training data, we can train it really well to do certain tasks under lots of different environmental conditions. So that's what they're doing with the driving data. That's why you sign over all your driving data to Tesla when you buy a Tesla, and they will then use it. They'll plug it into a big AI model and it will come up and go, this is how you drive. They're doing the same thing with their humanoid robots. They've employed a lot of people to basically wear motion capture suits and do jobs. Folding T-shirts, picking and placing objects, and various other things like that. And the aim of that is to basically program their robot to be able to do those tasks. And it will be able to do those tasks really well, but only those tasks. So we're moving now from something like an autonomous vacuum cleaner that can do one task to an autonomous humanoid that can do multiple tasks, but not loads.
I think the problem is data. So I think that's why you have a lot of these startup companies trying to get as much data as possible. I saw one the other day where they're paying people about £100 a day to wear glasses, and the glasses have the camera in, and just record their day pretty much. And you got then 10 hours of training footage for your robot. I think it's very exciting. I think with the humanoid robots, the other benefit, or at least in my mind, why they're going to be so big, and is that our whole world that we have created is in the mind of humans. It's been made for humans. Every door handle, every device, every tool is made for human hands, the human body. So if you can make a robot that looks and is the same size and has the same finger movements as a human, then it almost already fits into our environment that we have. So I think that's at least the motivation for me of why I think it would fit well in society. And then also you have the added benefits of, but there's a lot of use cases at the moment. I think some of the ones that are quite often talked about is you have healthcare. So like people say that as you have an aging population and less young people having less kids in the West, you can sort of have robots in healthcare, in nursing homes and things like that. Do you think that we will get to a point in the next, let's say, 20 years where people find it acceptable for robots to look after their elderly? Because I think one of the problems that I've had a lot of conversation with friends and people I meet, and one of the things I run into is the dilemma of adoption. It's how, if people feel comfortable buying it. And I always make the argument that, robots are just like any tool. You have in your house, you have a kettle, you have an oven, you have tools to save you time because you don't want to make a fire yourself, sort of thing. So a robot is obviously an extension of that, where you have it doing tasks for you and doing jobs for you. And would people get it? Do you think that that's going to be a challenge, that sort of changing the mindset of consumers to adopt it?
I think it's quite the humanoid robot has been a dream of robotics almost since the dawn of robotics. If you look at the first robot posters produced by Westinghouse, they had a humanoid robot in them doing tasks in the house. So from, I think it's the 1930s, certainly the 1950s. It would be slightly earlier than that, actually. It would be they're colour posters, I can't remember when they are. I should remember what they are, they're in my lecture course. But that was the first proposal, the first kind of idea of, here's what a robot will do for us. We'll come into the house and do jobs. Now, you can argue in the preceding nearly 100 years, that hasn't happened. And there's been a lot of developments of robots in that time. And there's a really simple reason why. The world is really, really messy. Really messy. You can do lovely simulations of a robot doing a task and do it perfectly. Part of the reason Tesla's training robots to fold shirts is t-shirts are really hard to fold because they're floppy.
Yeah.
And actually, it's really hard to model that because they fold and bend and do really, really awkward things. And then you have to be quite dexterous to be able to do that, but also quite reactive as well to what's happening. And that's the thing coupled together that robots aren't particularly great at. If you were to ask me, would I have a robot help to assistively dress me? It would fill me full of, frankly, fear at the moment, because the likelihood is it would hit me very hard at some point while it was doing something. Now, that's the issue when you think about some of the care tasks, and a lot of the care work that people are doing is around ideas around feeding, around support, around carrying, around particular tasks. And those there's a direct contact with the patient, but it's a fairly well understood contact. It's quite if it's a robot that's doing a feeding task, it's going to be offering food in a particular pattern to a person in a particular place, and there's not a lot of variability in that. There is overall, but actually in the process itself isn't going to change. You can repeat it, and it's not going to change. When you actually think about a lot of the tasks, a lot of the housing tasks that we do, there is actually a lot of variability in them. You just think about doing the washing up, there's a lot of variability in it, because every single thing you have to wash up has to be washed differently, has to be handled differently, has to be grasped differently, may need to change grasp as you do it to actually make sure it's clean. It need a varying amount of cleaning depending on how long you've left it. So actually to get everything off it in an appropriate, to get it clean actually needs a varying level of attention. Those are the sorts of things that we're not great at. Now, there's work out there to try and improve this, particularly looking without needing large amounts of data. So this is what foundation models and things like this for robots are looking at doing no-shot learning or one-shot learning, where we can just show a robot a task once and have it do it, or tell a robot we want to do a task and it's able to do it, no-shot learning. Now, ultimately, that's what we would want, because for the number of tasks that we need to be able to do, it's huge.
Yeah.
So actually, we need an efficient way for doing it, because there's no way we're going to program all of those tasks individually. That's kind of still where we are.
I mean,
We can do some of
you
them.
said before about like over the 100 years, there hasn't really been, we haven't really got to that humanoid robot, even though we've been trying so long. I would argue that the one big change in the last 3 years is how ridiculously far AI has come. And now it means that the sort of, as you said, with the programming the robot, it's almost impossible to program every task. But now with AI, you don't need to, because it can learn for itself. So, I mean, even what ChatGPT came out like 3 years ago, a bit over 3 years ago, and things have come so far since then. Do you think that we're close to a sort of inflection point with robotics where, there's some key piece of the puzzle is sort of put together and then rapid change is about to come? I mean, for me, the indicators of that is the large tech companies now investing so much money into it, and you are seeing the developments. So, I mean, you have big fields like quantum computing, AI, and robotics, but now you see that the big tech companies are talking about those so much more than they ever did before. So are we going to see all those three pieces of the puzzle? Is it as we develop those fields individually, do you think they're going to come together and make robotics work?
As a research question, it's a very, very interesting question, because if you look at all these fields, and AI is a really good field to look at, because if you look at the history of AI and how it's ebbed and flowed, it has its high times, and then people get to the end of what the systems can do, and it'll go into a winter where it's not developing quickly, people aren't really working on it. The question we've got at the moment is whether everything is in a place in order to be able to do exactly what we want. Now, there's two problems to that sentence. Whether everything's in place and whether we know what we actually want.
Yeah.
Because a lot of this is people asking the question, can it do? Well, that isn't necessarily the right question to ask. The question is, well, what do we actually want to do? What is the purpose? From an engineering perspective, what is the requirements for the system we're building? What is the specification for the system? Can we then build a specification for that set of requirements for that particular system? And do we actually know what it is? Because if we don't know what it is, and at the moment, I'd argue I'm not necessarily sure that we do.
I think the thought prompt I give to people is I'll say that, right now you might spend like £1,000 on a phone, for example, to like do things, or you might spend a lot of money on your oven or different things around your house. How much money, like, would you spend £5,000 on a robot that would do all your chores? If people are willing to spend, let's say, like £10,000 on a car to drive about, why would you not spend £5,000 to get a robot in your home to do the washing up and fold your laundry and do all those sorts of chores? Because it would save a lot of time. People work, let's say, throughout the day 9 till 5. They get home around 6. And then you have a few hours in the evening to sort of relax and do things you might want to do. But a lot of that time is filled up with chores that, you don't necessarily want to do. It's not done in your... So would people spend money on a robot? I feel like there is the incentive for people to buy one.
From that perspective, you can. I'll put a slightly different question on this, which is one I was chatting to a colleague of mine a couple of days ago about this, because we were talking about humanoid robots. He'd just come back from the European Robotics Forum, which is the major industry academic meeting place for robotics in Europe. I do normally go to it. I didn't this year. But the big topic this year was humanoids. And I'd done a couple of media pieces looking at humanoids. And one of the things that I dug out for that was I said, well, actually, what does one cost? If I wanted to order one up right now, what could I buy? And I found on one of the major robotics shops in the UK, a Unitary G1, albeit without hands, for just under 21k. So you could buy one.
Yeah.
Just under 21k. Now, admittedly, that needs grippers attaching to it, so you can add an extra few k there. But you can buy one for less than the price of a car.
Yeah.
Now. Right now.
I still think it's too expensive, unfortunately. I think for the mass market, I think it's too expensive for what it is.
Well, the thing I'll say, that robot, which is the Unity G1, in comparison to if you could actually buy an Atlas from Boston Dynamics, if you could buy one, because typically you can't, that price is substantially cheaper. Now, putting that price in context, if you wanted to buy a small robot arm, let's say a collaborative one, so that's a robot arm that you don't need some of the safety settings around because it can detect forces in its joints, so it can effectively detect if it hits something and kind of stop. One of those would cost somewhere in the region of 23k.
The thing is, I don't know if the price now is necessarily relevant, because once the market decides that there's enough demand and that you can make these sort of massive factories where you utilize economies of scale, the price does massively come down, like kind of what Tesla's done and things like that. So I would argue that the price now, with the lack of mass market adoption, wouldn't be the same as it would be once that it's kind of reaching that mass market.
I'd argue there's a slightly more subtle point. So Unitary is a Chinese company. They have massively invested in humanoid robotics. That robot is effectively a mass market robot at that price point, in comparison to a lot of other robots that you would buy. So collaborative robots I was talking about are a mass market robot. They are the types of things which are shipped out in massive numbers into manufacturing businesses, and they are more expensive than that robot currently is in its current state, which will be developed further as we go along. So actually, to me, that price actually represents, well, I mentioned it to my colleague and they were absolutely astonished that was the price point for it.
What, as
right.
It, so it would be so cheap that
yes.
Yeah.
That it would be so cheap right now. So I don't think you're actually going to see much more of a shift in price than that, personally, because that's what that robot costs in terms of R&D, in terms of everything else, in terms of what's there. Now, I could well be wrong on that, and hands up, come speak to me in 5 years, and if the price has gone down substantially, then I'm wrong. But that robot, in terms of what it is, in terms of what you can buy, at that price is crazy.
Yeah, no, that is insane. I think
Sorry.
as well that I saw I can't remember what the Tesla bots are called. I don't know if it's like Optimus or something.
It's Optimus. I want to say Optimus Prime, but it's Optimus.
It's Optimus. Yeah. I think I seem to remember reading that Elon Musk has quite ambitious plans for how many of those they want to make. They also want to make them quite cheaply.
They do, but their version of quite cheap, if I remember correctly, for the prices I've seen quoted, is 30 to 40k. That represents quite cheap.
Yeah.
So that's what I mean, is that when we talk about adoption for these things, it's still going to be a significant investment. I can't believe we're going to see a robot down at the kind of 5k mark that's going to do that kind of stuff, because the complexity of what you need and actually what goes into it, just buying the components, particularly servos and things like that actually are capable of moving that robot round, just the price point of that kind of element already brings it through that before the company starts making money on it, paying its employees and doing everything else that it's going to have to do in order to exist as a manufacturer.
Yeah, it makes sense. What do you think? Let's say that we wanted 30% of homes in the UK to have a humanoid robot. What is the biggest challenges to get to that point at the moment in robotics field?
I'd say two factors. Actually being able to work in such an open, varied environment. So if you look at Tesla's robot, Optimus, it's designed to work in a factory. That factory can have standardized lighting, it can have a layout that you know, it can have a layout that you can control, and actually you can roughly know exactly what's going on. And remember, it still needs careful training to work in that environment. Now put it into a crazy home environment with pets, kids running around, stuff everywhere, toys on the floor and everything else. Substantially harder environment to work in before you even then try and do a task in that environment where you have to find random things. Just take one example, doing the dishes.
Yeah.
I have no idea off the top of my head how many designs of taps there are in the UK, but I am willing to bet there are a lot. From combi taps, mixer taps, different shapes, different sizes, different function, different form. In certain places, the taps are switched on sides, so hot and cold are switched round if you've got separate taps. So again, the complexity that's there, that's in the environment, is massive. And you're just going, well, we're just going to drop a robot in and have it work perfectly first time.
Yeah, and even thinking as well, like if you have a robot and you're like, oh, can you go around the house and clean up all the dirty dishes, for example? Then you've got to look at each. It's got to analyze each of the dishes and decide, is this dirty or is this clean? It's got to figure it out almost.
Exactly. So the world, I say this a lot. The world is a messy place. That's why we'll see robots in manufacturing first, because it's a very carefully controlled environment, and you can control it perfectly because effectively it's closed. As soon as you go into a home environment, it's very varied, it's very open, it's very difficult to actually manage, and a lot of unexpected things can happen. And that comes into the second part of what I was, my second problem, which is safety. How do you prove if you're doing the washing that the robot hasn't put the cat in the washing machine?
Yeah.
Yeah. Now that's a silly example, but how do you prove it hasn't put a baby in the washing machine?
That's a good point.
How do you prove that it hasn't done this, it hasn't done that? Oh, it's carrying a knife round. Oh, great. What happens if it falls over? You can engineer a lot of difficult scenarios very, very quickly and very, very easily. And actually, they're quite normal because when I empty the dishwasher, I take the knives out and put them in the drawer. Subconsciously, I'm checking that there's nothing in my way before I put the knife in the drawer. Does a robot do that? Well, it's going to need to.
Yeah.
Actually, and there are a number of situations where we do dangerous things every day in the home. We're quite comfortable doing them because we're keeping a good sensory awareness. We've got a good spatial awareness of what's going on around us. Robots don't have that sense of spatial awareness to the same level. Actually, that makes it more difficult because, yeah, if a robot turns around with a knife, is somebody standing behind it? We have to ask a lot of these questions to make sure that we understand that a robot operating in that environment is safe. And ultimately, that's going to be one of the big barriers.
100%.
We have to prove that because, again, no one's going to want a system that's unsafe in their house or that can do something that can actually potentially harm someone. And we need to have thought that through.
Yeah, 100%. I mean, this is a discussion that I think about a lot where this kind of debate between safety and regulation, because I think it's one thing that divides like the EU and America, where I would argue that a lot of US states have quite low regulation, so that it doesn't hinder progression. So if you look at like Tesla, for example, with the self-driving cars, they are allowed to test the self-driving cars and are allowed to use them. So that means that you almost get a lot more data from what works and what doesn't. So it kind of progresses that technology faster. Whereas that isn't allowed in the UK or the EU because we have a lot more regulation there. So do you think that a lot more companies will invest in America and other countries that have less regulation for those reasons that I kind of outlined?
Not particularly. I think, in a way, it's difficult because if you look at different industries and different attitudes towards regulation, they are there for a reason. And actually, every country has stuff in place that lets you do most of this stuff, so you can still test it. So, as part of my background, I didn't mention it, but I'm a qualified drone pilot as well. I've gone through the tests and stuff, and I don't fly actually anymore these days, but I flew a lot whilst I've been here at Sheffield. And actually, there's a lot of regulation around it. And actually, it's a lot of very sensible regulation because there's a lot of people who would do some really, really, really stupid stuff. And actually, the regulation is there to protect and actually cause people to think about some of that before you go and do it. Because ultimately, if you took all the regulation away, it would be like the Wild West. People would just go around and do everything. And ultimately, the consequences of doing that would be substantial.
Yeah.
Now, there are lots of really good cases for this. There's a case study I often share around with people looking at. It was actually an authorized flight for a UAV. It was an 80 kilo, roughly, UAV doing a demonstration flight. And it went wrong. They had a flyaway for an 80 kilo UAV. It happened at Goodwood. You can go on the UK Civil Aviation Authority and go and look this up. They've got a beautiful view of the Isle of Wight from 5,000 feet. I think it's 5,000 feet before the batteries died. At which point it came out of the air. Missed a house about, I think it was about 10 metres it missed the house by when it came down. And if you actually looked at the circuits that were involved, the investigation goes through and explains where all the problems were, and they look at the circuits and they look at the issues with the circuits that were on board. There were lots of dry solder joints and all sorts of other stuff on board, and actually, so that meant things like the kill switch didn't work. So when they had a loss of communications and they had the flyaway, they had no way of basically just turning the motors off at 30 feet.
Yeah. Now,
that's the type of thing where if you go, actually, we don't really care what happens, people will do.
Yeah.
And that was in a controlled environment where we actually understood what was going on. And actually, it was a demonstration flight. It was a proving flight for the vehicle. But actually, there were substantial issues underneath in the vehicle. Mm-hmm. Now, if you just leave people to go and do stuff, there is a significant risk that people will do stupid things. I talk about this a lot in terms of AI because people talk about the dangers of AI. I'm not worried about AI personally. I don't worry about it. It doesn't keep me up at night. I don't worry about what it can do. I worry about what people will do as a result of being misled by AI. Because actually, that's where the most significant risk is. It isn't that the technology is bad. It's that people will make stupid decisions.
I think for me, the more, because I'm not worried about AI. Some people worry that AI, will run off by itself and sort of, take over. I'm not worried about that. I think I'm more worried about how bad humans will use AI. So for maybe making malware or the different sort of things that you might see like that. I think that's quite the concerning one because you cannot, when you have an AI that you program and train it on different malwares, you could almost then make bots that just spam out malware just everywhere. I think that's quite a concerning application.
You can, but remember that it'll only be trained on stuff that already exists. So it's only being trained on stuff that, so for example, exploits that it will use are exploits that you have to know about already. It's not going to come up with a new exploit. It's only going to use what it's been trained with. What I'm more concerned about with AI is that basically, like GPS, people turn off the sense switch in their head and believe what it says. If you corrupt or change what an AI presents or gives you, you can change people's opinion. And you can make people do silly things.
I think that is. I mean, we're in a misinformation age. I feel like yes, AI definitely makes it worse, but I think it's also, if anything, I think the AI might actually help the misinformation age because, all right, let's say for example, what I'm trying to gather as a point here is that before, when you had misinformation, I feel like people didn't really question it as much. Whereas now, because of AI, people are learning about deep fakes, they're learning about, AI videos or AI photos, and they're starting to question a lot more things they see. Even my grandma the other day, she saw a video of Trump talking, and she came and asked me, she was like, is this AI? Like, so if my 80-year-old grandma is now thinking about, is this even real, the video she's seeing, I think that sort of questioning of misinformation might actually be a positive thing.
I understand where you're coming from for that, but I also mean things like poisoning AI with various answers. So one of the things, there's a really good study which looked at an AI that was providing information to doctors for dosage for patients, and you could effectively poison it to give you any old dosage you wanted. So, and the problem isn't that, what I mean by this is people taking the answers from AI as gospel, that if you ask it a question, it gives you an answer.
Yeah.
And you take the answer is correct. Now, that answer is not necessarily correct. It is based on its training data. Its training data is the web, which is nonsense. So basically, you have a situation where you can train the system, and it can give you an incorrect answer, but if you're not questioning that, you won't know. So to give you an example for this, ChatGPT is famously bad at maths.
Yeah.
Awful at maths. I asked it to do an algebraic division. It got it wrong. I asked it to do the same algebraic division again. It gave me a different answer. I asked it again. It gave me a different answer that was also incorrect. I asked it a fourth time. It gave me a different answer that was also incorrect. Now, ultimately, I knew it was incorrect for two reasons. One is because I can do algebraic division, and two, because I asked it a question from a textbook and I had the answer in front of me.
Yeah.
I then told it where the question was in a textbook, and it still got it wrong. So ultimately, when the difficulty isn't AI, deepfakes, or anything else, it's people turning off I've asked ChatGPT a question and it's given me an answer, because the answer is not necessarily correct. And unless you go and check it, that's when you actually have to think about it. To give you another example for that, I was writing some software recently, and I thought, I'll ask ChatGPT just to do the last kind of simple bit. It was something in the robot operating system, and I was porting some code from ROS 1 to ROS 2, and I couldn't be bothered rewriting the launch file. So I asked it to write me a ROS 2 launch file. I gave it the ROS 1 launch file and said, please port this to ROS 2. It did not work. I had to rewrite the thing completely.
Yeah.
Because the answer it gave me was total nonsense. Now,
Yeah.
that's why I say we have to be thoughtful for the information that it gives us. Because if we turn off that sense switch, you can do all sorts of things with it. Because like I say, take the medical example. You can poison it to give you an incorrect answer. If you don't check that answer, then you would go and overdose a patient.
Yeah, I think
that to me is the real danger.
There is, yeah. I mean, that is 100% a massive issue, and I think, I mean, even so, I've been at uni for 4 years, and I've just tried to use ChatGPT for multiple things, and it just never ever works. It just, first of all, I mean, obviously it's university problems, so it's just infinitely harder. But I mean, it will be interesting to think about how it will affect younger people using it and growing up with it. So obviously, I only got ChatGPT in my second year of university. So for me, it was just never even an option to use it because the work I was working on was already too hard for it. It was too complicated. But for people now that, let's say, 10, 11 years old, who are just a lot younger and they have some easy homework that ChatGPT can easily solve, I do wonder how schools are going to deal with kids that are just doing all of their homework on ChatGPT. That it's almost, because it's not like, back in the day, let's say if you had a non-calculator exam, you could figure out the answer, but then you've got to show you're working out, and then that was sort of proof that you could do it by showing you're working out. But now with ChatGPT, it will literally go through step by step, so you could literally write down all of the working out. So it'll be interesting to see how schools sort of deal with that. I know that I've seen in the news recently that a university student was kicked out of uni for plagiarizing work with AI, using AI. And I do believe that we have to turn in our essay, like coursework, I think, through a software called Turnitin. I've heard that some people say, oh, I can now detect AI. I don't know if it's Turnitin or different softwares. Is the university talking about sort of how they're going to deal with AI and sort of writing coursework and things like that?
Yes. So there's a couple of factors in this. So Turnitin does have an AI button on it. So the kind of it's deep in the system. So a module leader doesn't have access to it, but the university can decide to use it or not use it as it deems fit. So it has that capability. In terms of ChatGPT itself and LLMs and OpenAI and that kind of side of things, yes, you're right. There's a lot of work which it is making quite simple, because actually, yes, for younger students, it can solve homework quite easily. It can write an essay, which does reasonably. Now, where we're going to have to get to is effectively looking at how to teach things like prompt engineering. So you actually know how to ask the right questions. And this is going to be something that comes up more and more as we start to redefine education, because AI is not going to go away. So actually, we need to think about how we capture that as part of the education, how we teach asking questions correctly to AI. Because you can ask the same question to AI in multiple different ways and get multiple different answers. Some are better than others. Actually, we need to know how people can give AI a good question.
Yeah, definitely.
That has to happen. Whether that is, and that has to happen from quite an early age as well, because there's no point suddenly starting when you're 18, because people will just go and use it beforehand anyway.
Yeah.
So at which point you're gonna layer problems into the system.
Yeah.
Now, some of that means saying, well, actually, as part of a homework, tell us the prompts that you used as well to do this if you've used AI. Or saying, we don't accept using AI for this, don't do it. Well, you're going to come a cropper at some point if you keep using AI to do things, because there is a point it's going to run out.
Yeah, definitely. I think mainly my main use case at the moment is, and perhaps it points to the fact that maybe I'm misusing it as well, because I use it as a teacher, in the sense that when there's like really difficult topics I don't understand, I will sort of keep prompting it to ask it questions about, I don't understand what these words mean, like how does this work, and I find it so incredibly useful as a teacher, because I'm someone as well that when someone explains something to me, I'd say I usually don't understand about 25% of it, right? So then I have to ask another follow-up question to understand that 25%, and oftentimes that leads me down a bit of a rabbit hole where I end up needing to ask 10 questions. Now, the difficulty with a lecture is obviously you're in the audience, you're watching, you can't really ask questions like that. So I have to go away from a lecture, and then I will go over the work and then have to ask all these questions to ChatGPT. Now, I have kind of accepted that, maybe 10% of what I ask it might be wrong, but I kind of just have to take that risk, because there's not really any alternative to me. Unless I sort of want to spend loads and loads of hours, fishing through all the books and try and figure out is it right or wrong, and it's just not realistic with the amount of work that I might have to do. So I think that's perhaps a choice that people can make, is how much misinformation are they willing to accept as a percentage of their knowledge? Because at the end of the day, most people's knowledge, at least some of it, would be wrong, and they're going around spreading that bit is wrong. So
yeah, I think the difficulty is the difficulty is you don't know what you're being presented with is misinformation or not, how much of it's misinformation. It's just information you're being presented with. There is a benefit to going and looking through textbooks, because you learn a process, you go through, you kind of have to they kind of force you down a pathway to look through things as a problem. I think ChatGPT is a good resource, and I think used properly, it's a really, really good resource. I use it as a sounding board. The things, just to, not because I'm necessarily looking for an answer to something, but because I want to throw some ideas around with myself. And actually, I can't always necessarily find someone to sit down and want to talk through pointless stuff with. So actually, it's quite useful to be able to kind of go round the houses with something around that, and that's great. And I think it's more of a question for how you use it. And again, as an information resource, it's always a bit like we would use. I mean, not quite when I was a student, I don't think. Actually, no, possibly, yeah. Wikipedia was around when I was a student, but it was always taken as this isn't a concrete resource that you can actually use because it's community edited and everything else. You can't use it as a definitive resource for the topics that you look at. It's a good guide.
That's so interesting. I would never have, up to this point, I just never even thought that probably people would have been having the same debates they're having about ChatGPT about Wikipedia.
Yeah. It's a good set of pointers. So, for example, if you're looking at for an academic topic, down the bottom of the article, there'll be a bunch of related links to papers and things like that, where you can go and read those papers. So it's a good resource to get you somewhere else. And in a way, ChatGPT is the same thing. It's a good initial resource, but actually, you shouldn't treat it as gospel because it may or may not be. Now, obviously, for technical subjects, it's more likely to be correct because, let's face it, it's probably had textbooks exposed as part of the training material and everything else, so it probably knows what they are. Providing it isn't maths, it'll probably be all right. But that's where we sit with it. And again, we had this debate endlessly with Wikipedia because, you can't cite Wikipedia, you can't use Wikipedia articles. Well, yeah, but it's still a good resource to actually start asking the question. It's still a good resource to say, well, actually, I can go read the Wikipedia page on this and see what it says.
Yeah.
Then I can go, oh, right, well, there's these useful things. I can go away and read those.
Yeah, absolutely. We're coming towards the end, so I have a final question for you. I want to know what sort of technology that you are most excited about for the future.
Does it have to be robotics?
It doesn't have to be robotics. It can be anything that that you've been perhaps looking at, or you're excited if that field develops, or anything like that.
I am going to pick a robotics one. And I'm actually going to pick. It was quite a controversial session. So, European Robotics Forum last year was in Rimini, which is beautiful, well worth going to. But it was a great conference, and then the keynotes were really, really interesting. So there was one from some of the companies who work in the area. There was one from David Scaramuzza looking at drones that have human-like behaviours and can basically beat human pilots in drone racing, which is fantastic. But I'm actually going to pick the third one, which was quite controversial, which was looking at not just autonomous cars, but the future of car ownership and autonomous driving within the city landscape. Because actually, if you have a fully autonomous car fleet of taxis that you can call on an app and that can come and pick you up, you don't need a car anymore. Or you can certainly, the necessity to have a car completely goes. So you effectively have fully autonomous personal transport. Now, in a cityscape, that completely changes the cityscape because you don't need the set of roads that you need. You can actually effectively re-greenscape a lot of your internal cityscape because actually you just don't need some of the road infrastructure. You can change how we use space. You can make it much more people friendly. You can make it much more of a community hub because it doesn't have to be a road with loads of cars thundering down it because you don't need as much parking. You don't need as much facilities at the side of the road. You don't need as much resource to be able to manage a smaller fleet of autonomous vehicles if you can persuade people to move towards that type of model. Now, I speak of this as a petrol head, as someone who likes cars, and kind of I totally appreciate the kind of that there is a disjoint there, but as a dream and as a model, I think it changes the way people live in such a fundamental way that it would actually change our cities massively, and it would change our experience of cities massively, as well as pollution and everything else. In terms of things that I'm most excited about, I'm going to pick that because that's a dream.
Yeah.
But actually, if you could realize it, the impact it would have on humans is massive.
100%. And I am a big advocate for cities that are walkable and aren't really congested with traffic. In terms of like cities that I somewhat dislike for those reasons, is you have like Copenhagen or Berlin. Their cities, they have like really long, like got 3-lane roads in their main cities, and I just really don't like that. There's discussions at the moment in London about making Oxford Street, not allowing any cars down Oxford Street, just walkable, and I'm in big support for that. Similarly, I mean, the tech, not that I'm most excited about, but one that I am excited about that's happening at the moment in Europe, in relation to your point, is flying autonomous taxis. So you've got quite a few European companies working on those. And that could too be completely change that sort of landscape where, if you've got flying taxis, that clears up a lot of space on the ground, and also means that you can kind of get around very quickly because they don't have to deal with congestion or anything like that. They could just go and do it. So I'm quite excited for that. But those I feel like are a long way away.
They are. We're talking kind of. That's not, and that actually, they both have big societal shifts in order to accept them as well. But actually, the benefit for doing it cures a lot of the benefits that we're talking about. Cures a lot of the issues that we talk about at the moment. Sorry, not cures the benefits. Cures the issues that we're talking about at the moment in terms of pollution, in terms of use of space, and all sorts of other things. Now, yeah, they're not going to happen tomorrow. They're not going to happen in 5 years. But actually, the difference in 10 years could be massive.
Absolutely. All right. Thank you, Jonathan, for coming on. It's been a lovely chat, and I will speak to you soon.
Thank you very much.